Hello students, this is the video that helps go over the remaining slides of the Unit 1 project. So taking a look here, slide number 7 is just a reference slide. It goes over the definitions of the independent variable, dependent variable, and constants. Remember that the independent variable is what you change on purpose at the start of the experiment. This is your cause, this is what you have control over. The dependent variable, on the other hand, is the result that you actually are measuring at the end, otherwise known as the effect, the final data that you are trying to collect. Keep in mind that everything else during an experiment should be kept the same. Those are called constants. This ensures that you only have one independent variable that you are actually testing. Remember, we talked about in class, if we change several things, different things about our paper airplanes at once, then we don't know what's actually causing one paper airplane to be better than the other because there are too many variables that are changing. So we only want to change one thing at a time. In our instance, the thing that we are changing is we are changing on purpose the fold of the airplane. So every airplane has a different fold. Again, you should have chosen 3 different options on how to fold your paper airplane on our previous slides, on slide 5. Then the dependent variable, what we are measuring, the result that we're measuring is obviously the distance that the airplane flies. Distance the airplanes fly. All right. And finally, constants are going to be everything else. So that's going to be things like the type of paper, the person who is throwing should remain the same, the strength with which the airplanes are thrown, the location, the weather, etc. So all of those things are things that should be kept the same, should be kept constant. All right, so that should help you with slide number 8. All right, so make sure, pause the video, make sure you understand this material right here now, and then this is basically what you need to answer slide number 8. So you need to identify the independent variable in our experiment, what we chose to change. I already went over that. Dependent variable, what we are measuring, the result we are measuring. And the 3 constants are everything else that should be kept the same. That should be kept the same. Again, we actually just went over all of these answers, so everybody should have the same independent variable, the same dependent variable, and pretty similar constants. All right, let's go ahead and move on here. So slide number 9 asks, what type of data are we collecting from our airplane experiment? Remember, we talked about qualitative data is data that is not numerical, cannot be expressed by a number. Sorry, let me get a different color here. Right, can't be expressed as a number, can't be counted, could be things like colors, descriptions, etc., etc. Quantitative data, on the other hand, quantitative has the word quantity in it, is data that can be expressed as a number. Can be expressed as a number, the data is counted, again, numbers and statistics. So think about if we are collecting distances, which is going to be like 3 meters or 220 feet, or let's see here, 10 actual feet, because I know some of you might use your actual feet, etc. All of those do in fact have numbers, right? So this is in fact numerical data. So that should be able to help you figure out which one of these has to do, which one of these has to do with actual numbers. Make sure you put an X next to the one that you choose. So just put your mouse in and put an X right there, okay? Again, we're measuring distance. Distance is in fact a number, all right? So choose the one that is related to number data, numerical data. All right, let's go ahead and keep on moving here. Slide number 10, you need to go ahead and actually throw your airplanes. Please make sure that you type your units here. Anytime we have a table, it's important to make sure that the units are in the actual top part right here. So you can see in all of these places, you should be typing your units. The units are the same units that you chose on this slide, right? So these slide, whether you chose feet, inches, centimeters, meters, etc., your actual feet, so on and so forth. Okay, so make sure that you type your units right there. Let me go ahead and delete this part right here. Come on. There we go. Okay, and you're going to go ahead and put in all of your data, right? So you're going to throw it 3 times. All right, so taking a look here, you would throw your first airplane 3 times, put its distance each time, right? So put your distances across here, right? So distance, distance, distance. Again, your units are already at the top, so you only have to put the actual number, right? So just put the number in here, number, and the number. Then you do the same thing with your second plane, throw it 3 times, I'll get a different color, right? So here's your next set of data, throw it 3 times, and you're going to go ahead and see where it goes. And then finally go ahead and do your last one, right? So last one, throw it 3 times and put your number data in here, okay? Once you have all of that number data, then what you're going to go ahead and do is you're going to find the average. Now remember that averages are found by adding up all of your data for that airplane and then dividing it by however many sets of data that you got. So in this case, we got 3 pieces of data. So we're going to add it all up and then divide by 3. This is really important. Your average should look very similar to your numbers. If your average is 3 times as big as your numbers, then you forgot to divide by 3. Okay, so let me go ahead and explain what that's going to look like. So you're going to add this number and add this number, and whatever that equals, all right, so that's going to equal the total distance that your airplane flew over 3 trials. Then you're going to go ahead and divide it by 3. So divided by 3, and that'll be your final answer right here. Okay, so again, take your total, add it all up together, and then make sure, really the most important thing here is to make sure that you absolutely divide by 3. Divide by 3. Same thing down here. All right, you would do the exact same process. So let me grab my pink here. So add these numbers up together to get your total, and then again divide by 3 to get your average, and that'll be your final answer in this column. And same thing with our last one, add up all these numbers. What does that equal? That's our total, but don't forget to divide by 3 every single time to get your final answer for the average. All right, so here we go. Again, most important part here is take that total and divide by 3. Okay, so that'll help you get your table. Awesome. Now let me go ahead and I'm going to go ahead and clear this out, and let's take a look at slide number 11. So slide number 11 says to define precision. Remember, this is something that we actually defined in class. So precision is how repeatable your data is, okay? And so the question is, so you can use this answer, so absolutely feel free to insert that as your answer. So the questions here are, how was your data precise for each airplane? So this means that did each of your pieces of data look the same, right? So if your data for here, if all of these, if all of these numbers looked pretty similar to each other, right? So let's say one was 6 feet, one was 5.5 feet, one was 6.5 feet. Those are all pretty close to each other. And so that means that it's repeatable, right? So was the data close and repeatable? If yes, then it is precise. Okay. If on the other hand, every time you flew your airplane, you got wildly different results, then that would not be precise. Okay. So let's go ahead. I'll come back over here. For here. All right, so let's go ahead again, the repeatability, how repeatable the data is. Okay, so again, if your airplane if your airplane went similar distances every trial, 1, 2, and 3, the first trial, the second trial, and the third trial for the same airplane, if your same airplane went similar distances every trial, then that is repeatable, that is precise. Okay, if your same airplane had chaotic distances for each trial, then it is not repeatable, and therefore it is not precise. Okay, so you should be able to explain that. You can say, for my airplane number one, my data, all of the data points were very similar. They were all around 3 feet. And so, yes, that was precise. For airplane number two, the data was all over the place, and therefore that was not precise. Okay, so something like that. All right, let's go ahead and move on and talk about slide number 12. So slide number 12, you need to graph the average distances flown for each plane. So again, that average is all the way over here. Remember the ones that you added it up and then divided by 3. Don't forget that you should have divided by 3. All right, so we're going to go ahead and I'm going to show you how to graph these. So let's take a look here. Okay, so what you're going to go ahead and do is you're going to go ahead and insert, and then you're going to go ahead and insert a chart. All right, and specifically, we are going to be inserting a bar graph. All right, this can't be a scatter plot graph because we have categories. We have different categories of airplane. The airplanes aren't a type of number, they're a category. Okay, so we're going to insert a bar graph. Okay. And once that inserts, it's going to insert a random graph here, so we need to go ahead and fix the data here. All right, so we're going to go ahead and we are going to go ahead and click the little caret right here. All right, this is called a caret. And when you click that caret, it'll say to open the source. So we're going to go ahead and open the source. And just so you know, when you open this, it does tend to scroll down automatically for some reason. So just go over here to the right and make sure to actually scroll up. So all the way over here to the right, make sure that you actually scroll up. Okay, so that you can see the data. All right, so here we go. For this, first off, we don't need this second set of data here, right? So this data right here, period 2, 89, 24, 37, 63, you can just delete all of that. We don't need that data. Over here, we need to rename these. We need airplane 1. So airplane 1, airplane 2, airplane 3, and we didn't have a fourth one, so we can delete this fourth row as well. So again, make sure you delete everything from column C and from row 5. Okay, so that was this column right here and this row right here. Okay, all right, so there we go. So up here, instead of period, we're going to write distance in centimeters. Okay, and we're going to go ahead and type in our distances. And so this is just going to be random data. Sorry, I should say average distance. So let me type in average distance. And sorry, not centimeters, let's do feet. Feet. Okay, so these are just random data points, so let's put in 10, 20, 30. Again, you should not put in 10, 20, 30. Your data should not look like mine. That is called cheating, ladies and friends. Sorry, ladies and gentlemen, that is called cheating. All right, so please do not make your data look like mine. Okay, all right. So here's my random data, 10, 20, 30. Okay, now the only thing you need to fix here is the title. So to fix the title, you're just going to go ahead and double click on the title. All right, so if you go here, just double click the title, and that'll allow you to edit it. Okay, so I'm going to go ahead and again double click that title, and I'm going to actually put in what this was the average distance in feet. For me, obviously your units may be different, right? So right here, sorry, let me do a different color. Right here, your units may be different. Okay, but you should still put in that that is the average distance. All right, so let's go ahead and take a look at that. Perfect. Okay, so this is going to be our graph right here. This is what the graph should look like. Airplane 1, airplane 2, airplane 3 with your data, not the random data that I have here. Again, your data should not look like mine. That is called cheating. And again, make sure you fix your title. It should say average distance in whatever units that you used, Okay. All right, so that is updated here. Now the problem is when you go back to your slide, it will not be updated on your slide. So then you need to go ahead and click this button right here where it says update. So I'll go ahead and click update, and now you can see that it looks exactly how it should. Again, you should have airplane 1, airplane 2, airplane 3. Remember, this is random data. Do not copy my random data. Use your average data from the slide. number 10, slide number 10. Okay. And don't forget to fix the title, right? Average distance. And then right here should be your units. So double check that this looks correct. Your units. Okay. All right, so that'll be your graph. That's all you need to do for that. I'm going to go ahead and clear this part out. And then last but not least, we just have the conclusion. So conclusion, super easy. Tell me which of your planes on average flew the best, right? So, right, look at your graph or the average distance from your table, right? So just figure out which of your airplanes on average tend to fly the best, either in my random data, right, airplane 3, or you could look over here from your right-hand column over here, okay? So then let's go ahead and take a look at the next one. Right, so how might you improve on that design, right? So think about what is another way that you could try to improve your design. What's one thing that went well for you and what's one thing you can do to improve? Okay, keep in mind that IDK, IDC, nothing, etc. are not acceptable answers. You need to be specific, and give real answers. All right, so there we go. We have a completed project here. At this point, you should have completed your project. I'm going to go ahead and show you now how to submit it. So if you're using the PowerPoint version, then you already have it saved on your computer. If you're using the Google Slides version, you need to save it to your computer. So you're going to go to File, Download, and then you can either download as a PowerPoint or as a PDF. I actually prefer if you download it as a PDF. But if for some reason you don't have Adobe PDF on your computer, then PowerPoint is fine. But again, I do prefer PDF. Okay, so download it as a PowerPoint or a PDF to wherever it needs to go in your computer, right? So let's take a look here at my projects examples. All right, so there's my example right there. All right, and just open it up, double check that it all looks right, that all of your text is on your slide, that your answers look correct. Perfect. All right, so now I'm going to go ahead and go to my course page. All right, so let's go ahead and go to our course page here. And then I'm going to go ahead and view as a student so that you can see your view. All right, and you're going to go ahead and submit this to the assignment folder. So you're going to go to Tools, Assignments. All right, and then you'll see the Unit 1 Airplane Project folder right here. So you can go ahead and click on this folder right here. All right, so you're going to go ahead and go right here, and then you will go ahead and you're in the folder. You'll click Add a File from your computer and Upload. And then you can go ahead and go to where your project was saved, right? So here was my saved project, and I'll go ahead and click Add. Okay, so again, to get to here, Tools, Assignments, click on the folder. So Tools to Assignments. Click the Unit 1 folder, scroll down, right, and then we're going to take a look here, right, add a file, click Add a File. Make sure you choose your file from your computer, and then go ahead and upload that. Upload and add. Okay, so there we go, and then all you need to do is go ahead and submit. So make sure you click Submit, and it'll say you submitted, right? So it should say that your submission was successful.